Hi everybody, this is Mrs. Lehman, and obviously you are watching Math with Mrs. Lehman. Thank you to the substitute for coming in for me. Please pause the video if you have any questions that need to be answered, or if you need extra time doing anything. We're going to start out with solving this bell ringer. It says solve for x equals 64. So again, little review here. What you need to do is the inverse operation. So 4 is a coefficient with x. That means it's being multiplied. You're going to divide each side by 4. When you take 64 and divide it by 4, you are going to get 16 as your answer. For question number 2 here, it says solve for a. 8a equals 96. So again, you're going to do the inverse operation, which is to divide each side by 8. You're going to get a equals 12. All right, and then the last problem that you guys had to solve for your bell ringer is what is 5% of 80? So remember the saying is over of equals percent out of 100. And what we're going to plug in now, what is, so we know that top one is blank, and this is of 80, so that goes on the bottom, and 5 out of 100. So we're just going to simplify this to 1 out of 20, and we know that's times 4. So 1 times 4, that must mean 4 is 5% of 80. All right, hopefully you did a nice job on that. I'll be right back. All right, we are going to go over your homework from yesterday. Let me get that page up here. Your homework last night was to do these questions on page 5. So before we begin, remember a statistical question has to meet 2 criteria. One of the criteria is that the answers has to vary, and you would get varying answers if you ask that question of a group, or if that question applies to a group of people or things. And then there are 2 types of data. It all says this in this box with the lesson summary, or that the lesson summary has here. 2 types. You have numerical data, which the answers are numbers, and then you have categorical data sets where you have, non-numbers. So those would be names, colors, labels, etc. All right, so the problem set said, for each of the following, determine whether the question is a statistical question and give a reason. So for A, I'd like you to grade your own on this, please. So make sure that you write down whether or not you got that one correct, and then fix it. Right? How many letters are in my last name? It doesn't want you to answer the question. It wants you to tell whether or not it's statistical. And that would be a non-statistical. The reason it would be non-statistical is that it does not apply to a group. You're asking one person, in this case yourself, how many letters are in your last name. So therefore the answers will not vary. And actually the rest of these are actually statistical. So if you look at this, all of these are statistical. We'll go through them one at a time. And the reason that they all would be statistical is that it does apply to a group. They do apply to a group. And the other part of that is you get varying answers. So answers vary within that group of data. Okay, so the second one here, B, it says how many letters are in the last names of the students in my 6th grade class. So that's going to be different for everyone. It's a whole group of kids in a 6th grade class. C says, what are the colors of the shoes worn by the students in my school? Well, everyone's going to have, there's going to be some variety there, some variability. So, and again, the group that they're asking, students in the school. So that makes it statistical. D, what is the maximum number of feet that roller coasters drop during a ride? So if you're collecting data from a bunch of roller coasters, that is definitely statistical. And again, some little roller coasters aren't going to drop that much, and then you have, the really exciting ones that drop a lot. So that's going to vary by roller coaster. Part E says, what are the heart rates of students in a 6th grade class? you know, that's going to vary amongst all the kids. F says, how many hours of sleep per night do sixth graders usually get when they have school the next day? Well, that's always a scary low amount, but it will vary, so that's statistical. And how many miles per gallon do compact cars get? So it's asking about multiple cars, not just one car. So again, that would vary. It's based on a group of cars. So those are all statistical with the exception of the first one. Identify each of the following data sets as categorical or numerical. So again, it's numerical if it can be answered with a number that represents a quantity, or categorical if it's for a name, if you can answer it with a name or something like that. So arm spans, that means how far is the distance from like the ends of your fingers to the other, on one arm to the ends of the fingers on your other arm, if you were to extend your arms out, you know, straight to the side. So that would be a numerical value. And I told most of the classes you do not need to explain your answer. Number of languages spoken by each of 20 adults, that's going to be numerical. Favorite sport, categorical. Number of pets, that's going to be that's going to be numerical. Let me erase that. So again, that's a number, numerical. Number of hours, that's numerical. Part 3, some of your answers for this part will vary. So what I'd like you to do right now is count the number correct that you got on questions 1 and 2. So there's a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I want the number correct out of 12. And the smart board is doing some weird things. Anyway, put the number correct out of 12 as a fraction. And I'm going to have the substitute write down the number when he or she calls your name, okay? And give them the number you got correct out of 12. All right, so I would pause the video at this point, and then once you're done collecting that, let's go over the rest of this. All right, the next part of this says, rewrite each of the following questions as a statistical question. So how many pets does your teacher have? The answer to that's too many, but what you want to do is change this, instead of just one teacher, how many pets do teachers at my school have? So maybe you take a survey of all of the teachers, so then you have a whole group to base it on. It could be, how many pets do 10 of your teachers have? It doesn't really matter. You want to make that a bigger group though. Part B, it says, how many points did the high school soccer team score in its game last night? So that's only one data set, one data point. It's just one game last night. You want to figure out the games that they have been playing, maybe this season. How many points do the high school soccer team score in each game this season? Or maybe you said in the past 10 games or something like that, right? But again, you want it to be a group of games, not just one. Part C says, how many pages are in our math book? Well, that's just, you know, a straight answer. So answers would be the same for everybody. So if we just base it on our one math book. So how many pages are in math books across New York State, maybe? There's lots of different ways we could change that. So maybe your answer I didn't give, but you want to make sure, looking at yours, how many, you want to change that number from just one book to a group of books. And can I do a handstand? Well, it's not asking you to say yes or no here. Maybe you want to change this to the statistical question. How long can students in my class do handstands? Write a statistical question that would be answered by collecting data from the sixth graders in your classroom. And then the next part of that is, are the data that you would collect to answer that question categorical or numerical, and then explain yourself. So I'm going to have the substitute pause the video at this point, and you are going to give some of the examples that you may have written on yours. So Go ahead and pause this and let's see what you guys came up with. Okay, you should have gone over that a little bit. And again, you want to make sure that your questions apply to a group. So you're not just asking one thing of one person or about one thing. You want to make sure you're asking a group of people or asking about a group of things where you're going to collect a variety of data from them. The next page is where we are going to talk about displaying the data that we collect. So it's called displaying a data distribution. So the first part of this is all about heart rate, and let's read about that. It says, Mia, a sixth grader at Roosevelt Middle School, was thinking about joining the middle school track team. She read that Olympic athletes have lower resting heart rates than most people. She wondered about her own heart rate and how it could compare to other students. Mia was interested in investigating the statistical question, what are the heart rates of the students in my sixth grade class? Heart rates are expressed as BPM, or beats per minute. Maya knew her resting heart rate was 80 beats per minute. She asked her teacher if she could collect the heart rates of the other students in her class. With the teacher's help, the other sixth graders in her class found their heart rates and reported them to Mia. Following are the heart rates in beats per minute for the 22 other students in Mia's class. All right, so we've got this big list of numbers. All right, so one thing you should always do is make sure you know how many data points there are. In this case, there's 22. Okay, so we know that we have to make a dot plot with 22 points on it. So one thing you should do is kind of look at your data and look at the high ends and low ends. In this case, the lowest number here, if you look across, is 79 beats per minute. And the highest amount that I see is a 90. So you kind of got heart rates all over the place there, but still within a good range. So let's see what it says. It says, to learn about the heart rates, a good place to start is to make a graph of the data. There are several different graphs that could be used, including the 3 types of graphs that you will learn in this module: dot plots, histograms, and box plots. In this lesson, you will learn about dot plots. All right, Maya noticed that there are many different heart rates. She decided to make a dot plot to show the different heart rates. She drew a number line and started numbering from 78 to 92. She then placed a dot above the number on the number line for each heart rate. If there was already a dot above a number, she added another dot above the one already there. She continued until she added 1 dot for each heart rate. So, one thing that I want you to notice here on Mia's dot plot is she has a title, right? Right here, I'm circling it, is the title. Right? When you make your own dot plot, you should have a title so anyone looking at it will know what your data represents. The other thing that you need to know is that this is labeled, right? So I circled the label here. This is representing heart rates and the unit it's measured in this case, beats per minute. All right? Now you see the number line, and again, you're working at a consistent scale. You do not need to start at 0. All right, especially with heart rates, because if you have a 0 heart rate, we're in trouble. But anyway, beats per minute. So the lowest number she had was 79. So she started a little below that with 78 and went up to 90. You want to make sure all of your data is going to fit on the scale that you choose. Now you'll notice she counted by 2s here because she's going from 78 to 80 to 82, 84, 86, 88, 90. So depending on the range of your data, how high and how low it goes, you may need to, adjust the scale of that. And we've talked about that when we've plotted points before. So what you need to do is then just plot a point or put a dot above each number. So in this case, we can look at this and see that there was one person who has a heart rate of 79. There was an 81. And then you'll notice right here, I'm going to circle it on the smartboard. That right there, 82, there were 2 people that occurred twice. The frequency of that heart rate was 2. All right, and then you have 83, which was the most common, with 4 people having that heart rate of 83. All right, and then 3 people had a heart rate of 84, 3 people had a heart rate of 85, 3 people had a heart rate of 86. There was 1 person who had a heart rate of 87, 2 people that had a heart rate of 88, 1 person who had a heart rate of 89, and 1 person who had a heart rate of 90. All right, so when you're looking at this data, you can kind of just look at it and notice that most of our data is kind of, you know, bumped up here in the center section. And that's going to tell us that that's where most of our data is. Okay, it's right in that 83 to, 86-ish range. All right, so let's see what the questions are that they gave us. What was the heart rate for the student with the lowest heart rate? So again, if you look back, the lowest heart rate demonstrated was right here, and that was 79. So I'm going to erase that. So the lowest heart rate was 79 BPM, beats per minute. What was the heart rate for the student with the highest heart rate? So again, if we flip back, we're looking for the highest heart rate. I think it was 90. Yep, 90 right here. Okay, so 90 beats per minute. And the next question, question 3. It says, how many students had a heart rate greater than 86? So greater than 86, we do not want to include 86. We want above 86. So that's pretty much from here over. All right, so we've got 1, 2, 3, 4, 5 of those. So let's go back to the next page and write down 5 students. What fraction of the students had a heart rate less than 82? So fraction, we want to know how many had 80, or less than 82, I'm sorry, out of a total of 22. So less than 82. All right, so we don't want to count 82. It's less than 82. So you'll notice there are 2 dots here, one at 79, one at 81. So we have 2 people out of, for every 22. So that means that would be 1 out of every 11 children have a heart rate less than 82. What is the most common heart rate? So we're going to call this the mode as we move further in this module, but the most common means the one that occurs the most, and it can have multiple answers to that, like you can have more than one mode, but in this case we only have one with the most. The most right here is 4, right? It has a frequency of 4, and that would be 83 beats per minute. So most common heart rate, 83 beats per minute. What heart rate describes the center of the data? So right now when we're learning this, we don't know the technical measures of center. You're going to learn mean, median, mode, which are measures of center, but you don't know those yet. So we're just going to kind of eyeball it and look at it and say, where does this data tend to lie? And you'll notice that it kind of bumps up here in the middle. So I would say somewhere around 84, 85-ish, something like that. So there's really not a wrong answer as long as it's kind of that area where most of the data is. So we're going to say probably around 80, 84-ish maybe. What heart rates are what heart rates are the most unusual heart rates? So if you look at that, like, we're looking for ones that don't happen, excuse me, typically. So I would say like 79, 90, those aren't typical for this group of people. Those are not commonly happening. There are some that didn't happen at all, actually. We could put those down as well, but let's just go with 79 and 90 for now. It says, number 8, if Maya's teacher asked what the typical heart rate is for 6th graders in the class, what would you tell Maya's teacher? Well, right now, based on that graph, I noticed that the most kids seem to have 83. So I would say 83 for now, and I'm basing that off of the mode. And in parentheses, I'm going to write mode. That means that's the one that occurs the most. We saw 4 kids that had a BPM of 83, and that was more than any other pulse. So number 9, it says, on the dot plot, add a dot for Mia's heart rate. So I can't remember what Mia's heart rate was. Let's go back here. Let's see. Oh, Mia knew her resting, it's right here, I'm underlining it in red. Mia knew her resting heart rate was 80 beats per minute. So let's go ahead down here and fill in a dot for 80. So you got to be really consistent here. You're not going to, intersect these dots with the line. You're just going to put a dot resting right above the line. Right, so that's where Mia is on 80. Right, how does Mia's heart rate compare with the heart rates of the other students in the class? So if we look back, Mia's heart rate is on the low end, right? So her heart rate tends to be a lot lower than these other people. So we're going to write that. Mia's heart rate is lower than most of the students in her class. All right, so finish writing that, and then we're going to move on. We're going to look at a few more dot plots, and then you will get started on doing some of your homework. And then tomorrow what you'll be doing is you'll be making your own dot plot. So, all right, hopefully I can get this wrapped up because we're going to run out of time here. All right, so let's go to the next page. It says Mia's class collected data to answer several other questions about her class. After they collected data, they drew dot plots of their findings. Here's a dot plot showing the data collected to answer the question, how many textbooks are in the desks of 6th graders? So again, she has a title here, dot plot of number of textbooks. And then she has a line drawn. We have 5, 6, 7, 8 potentials. That's a lot of textbooks. And then a nice label here for number of textbooks. Again, they're using a scale of 1 here. You're not going to have 5.5 textbooks, or that gets you in a lot of trouble because you ripped one in half or something. Anyway, so, what would you say is typical based on this? Take a look at that. What is the typical amount of textbooks that a kid at this school and in this class have? Well, you'll notice that 6 happens the most, right? So I would say 6 in this case is most typical. It says when the students thought about the question, they said that they all had about the same number of books in their desks since they all take the same subjects in school. The class noticed that the graph was not very spread out since there were only 4 different answers that the students gave, with most of the students answering that they had 6 books in their desk. Another student wanted to ask the question, how tall are the 6th graders in our class? When students thought about this question, they thought that the heights would be spread out since there were some shorter students and some very tall students in class. Here is a dot plot of the students' heights as measured in inches. So we've got, again, the title dot plot of height. We've got 45 up to 70, and we notice that this person's using a consistent scale of 5. So we've got somebody who is like 49 inches tall all the way up to 66 inches tall in this class. All right, let's see. Listed are 4 statistical questions and 4 different dot plots of data collected to answer these questions. Match each statistical question with the appropriate dot plot. Explain each of your choices. So, what are the ages of 4th graders in our school? What are the heights of the players on the 8th grade boys basketball team? How many hours do 6th graders in our class watch TV on a school night? And how many different languages do students in our class speak? So let's look at these and think about which ones make sense. Alright, so that's a little hard to see on here. Let me see if I can rewrite some of those numbers for you. Let's see. Okay, so dot plot A, let's team even in your book. Alright, so this says 9 and 10, and dot plot B says 0, that says 2, 4, 6, and 8, and then this goes 58 up to 72, and then over here it says 1, 2, 3. So, when we're talking about languages, for example, in that last one, how many different languages do students in our class speak? Well, obviously, you know, you're not going to have somebody who's speaking 72 languages, so we can eliminate D. 9 or 10 languages seems a little excessive. And, you know, dot plot B seems a little bit much too, with people speaking up to 8 languages. And somebody saying that they don't speak any language, 0, that's kind of ridiculous. So let's put C down for 14. So dot plot C. Let's look at 13. How many hours do 6th graders watch TV on a school night? Oh God, I hope that's not A. I'm hoping that's C. No, we already used C. Let's use B. That's insane too. All right, I need to pause the video. I'll be right back. Okay. Ages of 4th graders. So ages of 4th graders would be about 9 and 10. So that should be dot plot A. Dot plot A. So we've already used A and said that the language one was C. So that leaves B and D. Now obviously B would look a lot more like height than hours in a night. So B is going to be, oh, alright, so dot plot B is going to be hours. I have been teaching without the microphone. Anyway, let me reverse that due to my lack of editing skills. So anyway, ages of 4th graders, that's going to look more like 9 and 10-year-olds. Heights, those are going to be in inches, more like dot plot D. And then how many hours, I was kind of whining about that in the background. You could probably hear me. If you're watching TV for 8 hours, I do not know where you're finding your time to do that. 14, how many different languages? Well, you at least speak one, hopefully. So that would be dot plot C. All right, tonight for your homework, you are going to do question 10. All right, question 10. I'm sorry, page 10, the problem set there. So you're going to look at this. It's the dot plot of vertical jumps and of NBA players. A vertical jump is how high a player can jump from a standstill going straight up in the air. All right, that's pretty impressive. Some of these jumps are almost as tall as some of you kids are. Anyway, and me too. Yep, that's it. All right, so page 10 is your homework tonight. If there's extra time in class, which there probably won't be much, you can get started on that. Good luck to you all, and I'll see you back kind of tomorrow. Tomorrow I'm also grading New York State test, so I will see you on Tuesday. So Wednesday, I will see you on Thursday. But anyway, good luck with that. Have a great day. Bye.